you know how you asking for this? Standard deviation is what would be how would you get
Oh yeah, I got 1.13. How much? What do you use as yours? Okay, how are we doing? What did we get? Did we get an answer? Do we need another minute?
Yes.
I just use the whole number that I get. He said runs around until 6. I don't know.
Did you bring the evidence?
I did not bring evidence. What's that? So is it fine? I got 0.7065. I rounded. I just left it at 0.7065. Right? Yes. Yes.
You can do that.
Okay, let's go here. All right, the population proportion is 0.52. That means in the bucket we still have 52% are green. So my mu is equal to what? 0.52. Okay, and sigma is equal to
0.07.
okay 0.52 times 1 minus 0.52 divided by n 50. And when I do this, I get 0.07065.
Yes.
I'm still asking, if I'm taking a scoop of only 50 M&Ms and not 100, I'm still asking what's the probability that I get 60% or more green M&Ms. So my z is equal to 0.60 minus 0.52, and I'm going to divide that by 0.07065. And when I do that, what do I get? I got 1.13.
Does it make a difference?
Yeah, it's close enough.
So it's okay for you.
Okay, I see what my calculator is.
And I look up 1.13 in the table, and what do I get? .8708. And so 1 minus 0.8708 is 0.1292. And so what is the answer over here? What is the probability that my sample has 60% or more green M&Ms? 0.1292. About 13%. Yes.
Why do some calculators give different answers?
No, everybody's calculator should give you 0.07065.
Yeah,
It's just whether you decide to round that to 0.07, 0.071, or 0.077, or 0.0765. It depends on how many decimals you keep.
Oh, I see.
And you might get 1.14, you might get 1.13. Both of those are close enough in my opinion.
Do you want us to round it to a certain amount?
I would say keep as many decimals as you're willing to keep.
Okay.
Yes.
What we got is 0.1208. Would that be acceptable?
How
The
are you
reason
getting?
why we got 0.1208 is because I just I did whatever you do with the z-score, but I multiplied it by 0.07 only, and I got
What was your z-score?
1.14.
1.14?
Yeah.
So if you got 1.14 as your z-score, which I would accept, you should get 0.1271.
Well, don't you do 1 minus 0.8792?
Yeah.
I don't think it's 0.8792, I think it's 0.8729.
All right, yeah, you're right. I got it.
Okay.
I switched up, yeah.
Alright. Okay. Is this problem okay? Alright, so let's, I just want to make sure we got this.
Wait, oh my god.
Okay, so again, we're talking about the sampling distribution of p hat can be modeled by a normal distribution where the mean is p and the standard deviation there are a few rules or conditions that must be true for us to use this property.
It does say.
Okay, so a few conditions must be met first if we want to use the normal distribution as a model for p hat. Okay? Because if these conditions aren't met, then using the normal distribution does not do a good job of telling us what p hat is really like. Okay? Because the true distribution for p hat is different. But a lot of times these conditions are met, and when the conditions are met, the normal distribution and the distribution for p hat are very, very similar. So it's easy to use the normal distribution.
One more time, so you said if the normal.
So we're talking about the sampling distribution of p hat, which is how often should I get 60% green M&Ms, okay? The answer to that, the real answer to that, is actually complicated to answer, okay? It's a little challenging. We can use the normal model as a good way to model that, or figure that answer out, okay? because the answer to, what percentage of my sample is 60% green, or how often do I get that, it often looks very close to the normal model. Okay? But there's a few conditions that have to be met. Okay? And so here, these are the conditions that need to be met. So the conditions are, the sample must be selected at random. Selected randomly and independently. But I'll put in independently in quotes, or in parentheses, because if it's selected randomly, then the independently condition is taken care of. So the sample must be selected randomly. That's our,
selected randomly, then it's already
yeah, if I select the things randomly one at a time, then that means the selections are independent. Okay. Number 2, we have the sample must not be too big. Okay. And we check that by making sure our sample must be less, or our population has to be 10 times bigger than the sample. So this is sometimes called the big population rule. Population has to be 10 times bigger than the sample or larger. And then we also have the sample must not be too small. This might be called the large sample condition. Alright, so in this case there's 2 parts. N times P has to be bigger than or equal to 10, and N times 1 minus P has to be bigger than or equal to 10.
What do you mean by that?
Hmm?
What do you mean by that?
So what is N?
Size.
The sample size, and what is P? Is the proportion in the population. So all you have to do is you take N times P, and those are 2 numbers, you multiply those 2 together, and they have to be bigger than 10. And then N times 1 minus P must also be bigger than 10.
What if they're not?
If they're not, then these conditions are not met, and that means we cannot use the normal distribution as a model for P hat. Okay, so the 2 example problems we did with the scoops of green M&Ms, we answered those questions using the normal model. But in order for us to use the normal model, these 3 conditions need to be met. Okay, and if one of these conditions are not met, then we cannot use the normal model.
But would we still be able to get the...
You cannot use the normal model to answer your question, which means we cannot answer the question, at least in this class. Okay, so let's try something out. A company has 600 employees. Okay. We want to survey, take a survey to see how many are happy with the insurance plan. We take a random sample. Uh, 55 employees. Okay. So we expect population of employees as 90% satisfaction. 90% satisfied. Okay. Are any conditions violated? So I'll give you guys a minute to write down the problem, and then we'll go over the answer.
So what are we trying to solve? Are we trying to solve the actual question now?
I'm just asking, are any conditions violated?
Oh, okay.
Disjoint and mutually exclusive. That's covered. So, So there are three conditions for you to check in this problem. Okay, so let's check this one. The sample must be selected randomly.
Yes.
Is the sample selected randomly?
Yes.
Okay. So that's met because it says we take a random sample of 55 employees. Okay. The second condition says the sample must not be too big or the big population rule. And what is the big population rule? The population must be 10 times bigger than the sample or larger. So how big is our sample? Okay, our sample is 55 people. How big is our population? 600. So is our population 10 times bigger than our sample or more?
Yes.
Yes, because 55 times 10 is 550. Our population is 600. So the big population condition is met.
Wait, it's 55 times 10?
So our n sample size is 55, but to check this, we have to do 10 times our sample.
Oh, even if it's 10 times sample, so I'm assuming.
That's this one over here.
Oh.
I'm checking the second one, and I want to make sure our population is 10 times bigger than our sample.
To check the second one, you always have to times it by 10.
Yeah, so you just want to make sure your population is bigger than 10 times your sample. So 10 times our sample is 550, our population is 600, so this is met. Is that okay?
Yes.
Okay. All right, and lastly, large sample condition, is this met? So how do we check?
The 1 minus 0.60.
So we have to do
55 times.
n times p. What is p?
600. Wait.
P is 0.9.
P is 0.9. It says we expect the population of employees to have 90% satisfied. Okay, so P is 0.9. What is N?
55.
N is 55. Okay, so we have to check N times P. What's N times P? 49.5, right? 0.9 times 55. 49.5. Okay, and we also have to check N times 1 minus P. What's N times 1 minus P?
5.5.
5.5. Okay, 49.5 is bigger than 10. So that's good. But 5.5 is not bigger than 10. So that is no good. Okay? So 5.5 is smaller than 10. So this thing fails. The large sample condition is not met. So you have to check both N times P and N times 1 minus P. And both of those numbers have to be bigger than 10. 49.5, yes, bigger than 10, but 5.5 is not. So this condition fails. And so that means we cannot use the normal model to do any kind of analysis here. So are any conditions violated? The large sample condition is violated. Okay, so we cannot use the normal model. That's our answer.
So if that comes up on the test, we cannot.
We cannot use the normal model. That is correct. You have to write the large sample condition is violated. I will ask you which condition is violated.
So we just write 1, 2, 3.
No, write random, it is not random, or the big population rule is violated, or the
So
largest.
you ask us which one we could use, and which rule is followed and which one's not followed, right?
I just asked you, are any conditions violated? If yes, which one? Okay, and you know the descriptions of the rules here. Alright, are we feeling okay with this? Yeah? Should we try another example, or are we good?
We're good.
Another example, okay. Alright, so we'll say in elementary school, as 500 students, we pick a classroom of 30 students. We expect 50% of students to be to be bus riders. Okay. Are any conditions violated?
doing this, do you wanna, let's say, let's say the random is not met, do you want us to continue to see if the other two are met, or if we see the first one is enough, we just stop there?
I would say check all three.
Okay, so,
But it's possible for two of them to not follow, right?
Yeah. It's possible
so
for all three to be left.
Do you want to just, let's do all of them?
Yeah. Check all three always.
How do we check if it's a large sample? It's only comparative. If it's a large sample, it's not comparative.
Yeah, the one is the large one, so they have yeah, the large
Okay. Are we ready? Is our sample randomly selected?
No.
No. Okay, so random condition is not met.
What's the harm in it?
No, it just says we're picking a classroom of 30 students. Okay? If it's going to be random, we need to select 30 students at random one by one.
Oh, okay.
Okay? Big population, is that met?
yes.
Okay, our sample is 30, and our population is 500. Okay, so our population is over 10 times our sample. So this is met. What about the large sample condition? Is that met?
Yes. Thank you.
Okay, so n is 30, p is 0.5. So n times p is 15, and n times 1 minus p is also 15. Both of those numbers are bigger than 10. So that one is met. Yes?
So it will explicitly say we pick the students randomly? The word randomly will be there?
Yeah, you need to see somewhere in there something saying that the students are picked randomly.
It'll clearly identify that it's random?
Yeah, and here we're picking a classroom of 30 all at once, okay? So that's also not going to be random. Even if I said I selected the classroom at random and I picked all 30 students, that's not a random sample because random independent means we're selecting them one by one at random. Okay? Or if I selected 30 students at random, then yes, that would qualify.
Okay.
All right, let's take a short break.